So I'm going to present like this talk, mining from telemetry, investigating malware and privacy risks from user collected data. So first of all, thank you for having me among you, for inviting me for this talk. Just a quick presentation about myself. So I'm currently a security researcher at Norton Research Group. But I was a PhD student like in the last 4 years at Eurecom, a university in the south of France. And during the PhD, I've been mainly working on predictive security and large-scale measurements. Basically, the idea is to use telemetry and data to perform some prediction for security-related events. I don't know, for example, cyber incidents or malware infections or privacy risks and so on. Currently, I'm diverging a bit like from those subjects. Like I'm more focused on applied ML for phishing and malware detection and classification. Okay, so a quick look at the agenda. So what I'm gonna talk, I'm gonna do a brief, like really a quick introduction on predictive security, on proactive security, and the importance of data in proactive security. Then the importance of telemetry for us to be able to predicting security event. And I'm going to present two works we have carried in our group. So one is related to malware risk. It's basically investigating good indicators to predict systemic and systematic risks in malware in the consumers and enterprises environment for what concerns malware. I will come back to those concepts later. And then the other work is about privacy risks. So basically what we can say about the knowledge that tracking organizations have about users by using the telemetry. And then of course I will give in some conclusions. Okay, so let's start with some background. So today we are surrounded by technology. So we use technology everywhere. I couldn't think to any single action that doesn't involve technology nowadays. So we read through technology, we work, we pay, we measure time and so on. And of course, all those objects, like while we use those objects, we produce a lot of data. And if we think that, this is real, this happens in all the world, I mean, this data is really a lot. Like there was a recent study that estimated this, the data that is produced every day is around 2.5 billion gigabytes every day. And it's not surprising that nowadays data is considered the new oil. Why? Because of data analytics. So we can use the data, for example, to understand the current market landscape. For example, one enterprise could use data to introduce new products in the market. For example, we use data to understand customers' preferences and tailor them with targeted advertisement. Or, for example, some companies can use the data and do some, analysis to try to solve problems in the production process and improve the overall efficiency. So, what about the use of data in cybersecurity? Well, I would say that there is no exception. For example, companies collect data and analyze it to spot anomalies. For example, if there are potential frauds or unauthorized intrusions, malware infection, hardware failures, and you name it. So in this scenario, mainly data is used to detect the problem. For example, some frauds, some malware infection, some failures, and so on, and to try to react to those problems, to try to solve them. But actually, can we try to do better? Like, can we try to use this data to predict future problems and then try to avoid them, or at least try to minimize their impact? For example, in the context of cybersecurity, can we try to use data to predict the most vulnerable parts of a system with the purpose, for example, of measuring which of them have the highest likelihood of being attacked? And can we use this information to prioritize security spending for hardening those parts and to protect the most valuable assets we have in our company? And this is, what proactive security is about. So you try to use the data to predict potential problems, potential failures, and try to avoid them or to minimize their impact. Now let's look, at the value that telemetry, at least in our case, has data to try to, predict future events. So telemetry can help us in measuring cyber risks. So for example, I was mentioning before, can we measure which risk we have for a given part of an enterprise to be attacked? And this, like user collected telemetry, can help actually in conducting a quantitative risk assessment that is not just qualitative. Okay, this part has high likelihood of being attacked, this other part has a low likelihood. Can we put a number on those? And also, are there security risks that we can predict? Are there security risks that we cannot predict? And which kind of indicators should we use in our models that are good to reflect like the risk? And also, which data sources do we use to extract them? Are there reliable data sources that we can trust and we can use as a ground truth to predict our events? So in this talk, I'm gonna, as anticipated, talk about malware and privacy. So in the first part, I will focus on risk indicators of malware encounters. And we did this study using the telemetry in the consumers and enterprises environment. And we analyzed the systemic and systematic nature of those risks. Okay, we'll come to this, difference later. And also, I will stress, like in the second part of the talk, the importance that data sources, so a good data source has in understanding those risks. And for example, how we can combine externally and internally collected data sources to come up with a better measure of risk. And we will see how this is possible with privacy risks due to web tracking. Those two parts are, they come from two different publications. So one is a comparison of systemic and systematic risks of malware encounters in consumer enterprises environments. It was published at the journal TOPS. And the other one is When Selling Met Trackers, Web Tracking from the User Perspective. And it was presented at last Usenix last year. Okay, let's start with the first subject, like the first risk investigation on malware in this talk. So let's give a definition of systemic and systematic first of all. So mainly in finance, so in economics, systemic is also known as diversifiable risk. So this risk is unique to a specific company or industry sector or market segment. And we can somehow reduce this risk, this kind of risk, if we diversify our investment. On the contrary, systematic risk is also known as non-diversifiable risk. It's not specific to a certain industry or market segment, but is inherent to the entire market. And so it's not specific to particular stock or market segment or industry segment. And as you can imagine, we cannot really diversify. We cannot really reduce this kind of risk with investment diversification. Just to be clear, let's give an example of those two. So for systematic risk, for example, in the crypto market, let's say that you monitor for, coins, and as soon as you diversify your investment, like you put your money on 4 of them, for example, one might be going good, the other one might be going, pretty bad. But, on average, more or less, this is what you get. But on the other end, on the systematic risk, let's say that tomorrow all the governments say, okay, crypto are illegal. No matter where you put the money, you're going to go down. So just, this is, the main difference. So why between those two entities that we have in our first study, so consumers and enterprises, there should be systemic risk. So one really related to, the market or the segment. So first of all, because consumers, so home users, usually on their devices just deploy a single antivirus that, if there is some problem, it's going to pop a notification and it's going to tell the user, okay, do you want to solve this? Yes, and it's gone. On the other end, this is also true in enterprise environment, but what happens is that in enterprise environment, there is also something else related to the security posture. For example, enterprises have firewalls, intrusion prevention, and intrusion detection system. But also on the other end, in enterprises, there are also security policies that tells employees what you can do and what you cannot do. So for example, you are not allowed on your laptop on your enterprise laptop, business laptop, to install whatever software you want. And so this, creates a difference in the security posture of the two. Why instead there should be systematic risk? So why those two parties should suffer, from a baseline risk that is, common to the two of them. So first of all, because two parties are active and just use information technology, the same information technology. And so simply the fact of being active, so indicators like activity days, activity hours, and the number of files that, are present on the machine can introduce systematic risk. But also, both consumers and enterprises rely on the same software. So can we say something? Can we use the vendor number? So how many vendors do they have on their machine and the reputation of those vendors to measure, to say something about this systematic risk? Both of them are located in different areas. So we can say something like, okay, if you are in a particular location, you're going to suffer from systematic risk just because you are in that location. And simply because you have a recidivist approach. So you encounter malware in the past. So simply because of that, you are the so-called repeat player. So simply because you have encountered malware in the past, this is gonna, give you more risk to encounter it in the future. And also on the enterprise side, can we say that simply the biggest you are and then what you do, so your sector is gonna introduce systematic risk. Just a quick personal note. One might say, okay, but those factors are obvious. You just say, okay, for example, the more you are active, the more your risk is going to increase. And I would, just anticipate that those factors are not obvious. This is a classic complaint we got when submitting this paper in our reviews. Say, okay, those factors are just obvious. So first of all, they are not obvious because as we will see, like some factors as time activity, the reputation of the vendor, the repeat player, and the enterprise side, they are not simply met. So it's not that you simply increase them and you're going to increase the risk. And second, in our contribution, we always, as I've said at the beginning, like the use of telemetry and the use of data can help us to put a number of this risk. So it's not just, okay, it's obvious, it's going to increase, but it's going to increase of this factor. So for the first study, we used the telemetry of our company, and the telemetry we have telemetry data about 371 million hosts located more or less all over the world. For each of them, we have the malware encounter, so we know which kind of malware, which kind of signature was triggered on their device. And we also have information about the kind of files present on the machine. So we have 5 billion events, and we count 70,000 different vendors. So let's look at the first difference between the two segments, consumers and enterprises, that is systemic risk. So if we simply take the two parts, home users and enterprises, and we simply count how many devices in both parties detected malware, we have this. So for enterprises, it was 12%, and for consumers, it was 10%. So you might say, okay, in enterprises, I would have expect the other since the security posture is better in enterprises. But in this case, we have this 2% difference for enterprises. But then if you start, looking at particular subclasses of devices, so for example, the devices that are active all the 12 months of our investigation period, you find the other result. So the malware encounter rate is increasing in consumers. And also if you, extend this, you consider those that were really active, so all the 12 months and 20 days per month, you find a huge difference. And this suggests that, so at first, the security posture, so having a better security posture is better in enterprises, like if you look at the machines that were more active. We also looked at the malware subclasses that we found, so how diversified is the malware that we find, on the machines of both parties. And we found that, so in enterprises, 80% of the machines just encounter one subclass of malware, so they encounter a single malware type. On the other hand, in consumer environment, this is true for only 50% of the of the devices. And this suggests that maybe, the security policies of installing only particular kind of software, really works in enterprises environment. We can also see this when we look at the breakdown of the classes. So this is more or less how it looks like. This table, is telling us that, for example, for enterprises, 80% of the devices detect Trojan, and in consumers, 47. So what we can see is, there is a similar behavior. So Trojan is the most encountered class in both parties. But then just if we look slightly below, the potential unwanted application, this PUA and hardware, are really different in the two parties. So they are more pronounced in home users, but, quite low in enterprises. And since, those two classes of malware, potential unwanted application and hardware, usually are shipped, when you install random software, we can see how, security policies are important here, because, in consumer environment, so if you are at home on your device, you can do whatever you want. You can install and download the software that you want, while in enterprises, you cannot. On the other hand, what we noticed is a different behavior when considering behavioral signatures. So what are behavioral signatures? Is that you don't simply, is this malware that you don't simply detect by looking at the signature, so basically at the fingerprint of the file on the device, but are those signatures that are detected, for example, trying to emulate the file or with, some machine learning based heuristics. And as we can see, like the curve is more pronounced in enterprises. So this is suggesting us two things. So first of all, that since those are more complicated signatures, well, enterprises are subject to more sophisticated attack, but also this can be due to the fact that, for example, in enterprises environment, you compile more custom code, and this we observed is triggering more behavioral signatures for which, like, the antivirus one was not, whitelisted against. So this custom software was not really tested, and the antivirus is, not really confident about his decision. So let's now look at the other part, so systematic risk, the undiversifiable part of the risk. So how did we carry this analysis? Was to use a generalized linear model. So basically the idea is to model the malware encounter risk, so whether a machine encounters or does not encounter malware, as a simultaneous combination of all the indicators that we mentioned before, like activity days, hours, repeat players, vendor number, geographic position, and so on. We built a generalized linear model for consumer and a generalized linear model for enterprises. And at the beginning, we just consider all malware families. So just, okay, do you encounter malware, any type of malware or not? And then we do it also separately. So do you encounter potential unwanted application, and we build a single model for it? Do you encounter viruses, and we build a single model for it for both classes. So how do we train, and how do we analyze the result of this model? So let's take an indicator. So for example, the activity days. This is an integer, and it ranges from 1 to 31. It depends on the month. So what do we do is to divide this indicator strategically in bins, meaning that the bins that you obtain should be meaningful. For example, related to the activity days, should more or less be consistent what activity days means in this context, and also balance. So we tried to divide the data that we have in bins so that we have more or less the same number of machines for each bin. Then we pick a reference one. Usually for integers, like in this case, we pick the lowest one. For Boolean values, like, okay, did you encounter malware in the past or not? We pick the false value. We train the model, and then we compute the odds for each bin. The odds is simply the probability of encountering malware divided by the probability of not encountering malware. So for example, for each bin, we have an odd, and then we compute odds ratio. So we divide the odds for each bin, let's say the odds of activity days 5 and 8, divided by the reference bin that we took, so the lowest one, 1, 4, and we compute odds ratio. This is a value. And what it means, for example, in the first case, if this value is greater than 1, your risk is higher than the reference bin. Let's look at the first indicator now. So those are the results: time activity, the days, and the hours. So we want to understand here, is your risk of encountering malware increasing if you are more active, like on both sides? You are active more days and more hours per day. Well, as you can see, like odds ratio are increasing. So, I mean, this was kind of expected. But if you look, at the last two bins, the behavior is a bit random. And this is the same for activity hours. So then this number, odds ratio are increasing if you are active 4, 6 hours per day, 7, 9 hours per day, with respect to being active 1, 3 hours per day. But then we observe again a weird behavior. So this is more clear if we put those aggregated on a plot. So this is the plot of the day. And this is, when for enterprises, this odds ratio after 20, 21 days starts to be random. And for activity hours, in more or less around 7, 8 hours, the curve starts to be completely random. And so, as I said at the beginning, like more activity does not necessarily mean more risk. What we understood from those, from those plots is that the activity days, around 2021 is more or less the number of months you work per month. And 7, 8 hours is more or less the number of hours you work per day. So it's not that the more activity, the more malware, the more risk. Is okay, the more activity means the more activity that a human is doing on the machine. And this is more evident if we consider, for example, some classes of malware as adware. Like if you consider the machines that are active more than 19 hours per day, so those machines are probably servers or machines that are not really used for interactive tasks, so there is no human there. You can see that the odds ratio are basically almost negligible with respect to the reference bin. So it really means like that you need to consider like human interaction to the machine and not how much the machine is active. Then we also consider like vendor reputation. So what we did here was to understand, okay, what if we install on a machine only reputable vendors? Is this reducing the risk of encountering malware? So to carry this study, we identified the 20 most prevalent vendors in our telemetry, and then we simply classify a machine as, okay, this machine is installing only reputable vendors if we only observe those 20 most prevalent vendors in this machine. And as we can see, like if we consider all malware, like the impact that this factor has on the result is like almost, is not important. Like, either you have the most prevalent one or you install whatever you want, more or less, there is no impact. But if we consider like particular classes of malware again, like potential unwanted application and viruses, well, if you have only, top 20 vendors, this is gonna reduce the risk, of encountering malware for those particular categories, potential unwanted application and viruses. We then look at the repeat players. So here we want to understand the fact that you encounter malware in the past is giving you some, penalty in encountering it again in the future. And indeed, we notice that, yes, this is true for every malware family. But again, this is more evident if we consider particular classes of families as adware, viruses, and worm. So the fact that you encounter these particular classes of malware in the past is going to tell us, okay, this is a good indicator to say that probably you will encounter it in the future. We then look at enterprise sites, and as you can see, like the impact of this factor is not really, marked, I would say. And this is very important. Like if you look at this plot here, or the orange curve is a bit small. I don't know if you can see it. It's almost flat. It's almost, very shaped, I would say, shaped around, the average. So in this plot, on the x-axis, there is the enterprise sites. For example, a small enterprise with 50 employees, or big enterprises, more like with the 50K, 500K employees. And then each point is saying, okay, what's the percentage of devices among these 50K, for example, that is encountering malware. And more or less, like you see, this factor is flat, like, there is a plateau. It's not like that the bigger the enterprise, the more risk of encountering malware. And this is very important because if you consider, for example, some contexts like cyber insurance, those people are pricing insurances for companies, also taking into account the enterprise side. So they say, okay, if you're a bigger enterprise, probably your risk is higher. And so we will, your rate will be higher. The premium that will be assigned to you will be higher. And at least as we are showing, with these results, this needs more investigation because what we found with malware is not telling us this. So some takeaways from this work. So first of all, for systemic risk, we noticed that between the two parties, so consumers and enterprises, so there is first of all a different encounter rate and a diverse set of malicious software, and that adware and PUA are more prevalent among consumers. On the other end of systematic risk, we really saw that there are some good indicators that are telling us, okay, this systematic risk exists also in a cyber scenario. Some indicators really reflect systematic risks, but other indicators, for example, as the enterprise sites, they need more investigation. A key takeaway is that to be able to give a correct estimation of the risk, you should consider both. Let's now move to privacy risks and try to present the second work when selling web trackers, web tracking from the user's perspective. So this work is more, focused on understanding the importance of data sources when trying to quantify cyber risks, and in this case, privacy risk. We are talking about web tracking here. So as you know, web tracking is a widespread practice. So every website nowadays, not every, but a vast majority of websites, they employ web tracking for various reasons. So for profiling users, for analytics, for serving targeted advertisement, you name it. And there was a recent study 2 years ago that was measuring the presence of big companies, big tracking companies, like for example, Google and Facebook in websites. So those studies found that, for example, Google is present in 40% of the top 1 million websites, and Facebook is present in 18% of the top 1 million websites. So those studies were used externally collected data. So they were simply visiting the URL and looking, okay, is Google, is Facebook, is this tracking company present there, by looking at the script and by connecting back the script to the tracking organization. But so the question is, can we look at those numbers from a different perspective for what concerns privacy risk? So privacy risks are related to users. So what do these percentages mean for users' privacy risks? So for example, is the fact that Google is present in 40% of the top million websites mean that Google knows 40% of the information related to the user? For example, 40% of the user browsing history of the URL that are visited. But also from a different perspective, can we say something else on privacy risks? For example, can we say something related to the timing? So how fast do users lose their privacy? And how frequent do they encounter tracking organization? And as you can see, like externally, so if you visit the website, you cannot really tell this. So you need a different data source. And this data source is internally collected telemetry, so telemetry of our customers. We have the browsing history, so we can analyze which kind of domains are visited. We have this telemetry, at least the telemetry used in this study, about 250K users all over the world. And for each of them, we have the day, the hour, and the domain access by each user during 1 week period. What we do in this study, for a total of 2.3 million visited websites in a week, like a distinct website. So what we do in this study is to use this data we build a custom crawler that visits each of these 2.3 million websites, collects tracking organization. So for example, is Google, is Facebook present there? And then for a total of 6,000, we more or less measured 6,320 distinct organizations on those 2.3 million websites. So let's talk about the timing. Can we say something on how fast do users lose their privacy? So with this, merging the two externally and internally collected information, we measure that on average, in 1 week period, our users encountered 177 different tracking organizations that are tracking them. So they know which kind of website, which kind of categories of website they visit. But the most important thing is that we measured that after just 2 hours, the user has already encountered on average 50% of them. And this number raises to 84% in the first half a day, so 12 hours, and 94% in the first 24 hours of browsing. So this is telling us that, okay, no matter how many tracking organizations do you encounter at the end of the week, after just 24 hours, all of them are already tracking you. So all of them already know about it. The other investigation was about, the amount of website that you visit and the privacy risks. In other words, is it true that the more websites you visit, the more trackers you encounter? So in this plot, on the x-axis, you have the number of websites visited by each user. So each dot is a user. And on the y-axis, there are the number of tracking organizations encountered by each user. And as you can see, this is quite linear. So yes, it is true. We almost found a perfect correlation between the number of the website and the trackers encountered. So is it true that the more you browse, the more trackers you encounter? But can we say something on, for example, the outliers of this plot? Like, for example, the user that we called upper outliers. So the users that really don't browse a lot, like they browse very few websites, but still encounter a lot of tracking organization. So what do they do to have, this effect? And on the other end, the lower part, lower outliers. So are there users for which, even if they browse a lot of websites, they encounter really few trackers? So why? I mean, do they browse particular category of website? Do those websites have particular security features and so on? So first of all, we came up with this trade-off, so reputation privacy. And what we discovered is that if you browse less websites, but you encounter more trackers, you are browsing very reputable websites. So more reputable website, like for example, website of news, sport, and very popular websites, they have higher privacy risks, which means that they have a lot of trackers. So if you browse more of those websites, you're gonna be tracked more. And we also discovered another trade-off, security privacy, that is basically the other way around. We discovered that basically if you browse less reputable websites, so websites for which our product was saying, okay, this looks more malicious, so the security risk score, not the privacy, the one related to malware serving, for example, is higher, there are less privacy risks. So those websites, that look more malicious, they are not really interested in tracking users. On the other hand, if you browse really secure website, which is correlated to browsing more reputable website, your privacy risk will be higher. On the timing side, we also asked us another question. So what about trackers re-encountering frequency? So with which frequency do I re-encounter the same tracking organization? So how is it tracking me? And this is to answer another question. So can I simply prevent tracking by simply deleting the browsing histories? And if this is possible, how frequent should I do it? So in this table, there are the most prevalent 5 tracking organizations in our dataset: Google, Microsoft, Twitter, Yahoo, and Rubicon Project. And as you can notice, like a user on average encounters those tracking organization every hour, slightly above 1 hour. And I would underline here that 1 hour is the lowest granularity that we have in our dataset. So probably this number will be lower. And what does it mean is that if you want to prevent tracking by simply deleting the browsing history, you should do it basically every hour, which is not really practical. So you need other solution to do it. Let's now look at another side of the story, so the knowledge of the trackers. So we basically measure that on average, for each user, Google and Facebook respectively know 64 and 30% of the browsing history, meaning that Google knows on average 64% of each website that you, of 64% of the browsing history along 1 week. And if you recall at the beginning of the presentation, like we measured that Google and Facebook were present on 40% and 18% of the top 1 million. So this is telling us that if you only consider the externally collected data, so if you only go on the website and measure, okay, is this tracker present there or not, you are actually underestimating the privacy risks that web tracking is introducing, because what we found was almost the double of the knowledge that those organizations have. And more importantly, those numbers are just lower bounds, because trackers can know more thanks to data sharing. So even if an organization is not present on a website, the organization can know that the user was there because it receives data from another organization. And unfortunately, this happens under the hood, so we cannot really measure with our crawler this phenomenon. What we did to estimate it is to use an estimation. So we estimated how much would this knowledge increase if organizations share the data. And we did it in two fashions. So first of all, we used already known collaborations. So previous studies already analyzed, already found that organizations were sharing data, for example, with cookie syncing and so on. So based on these known collaborations, we estimated that the knowledge that they have can increase from 5 to 10% if only 2 organizations share data, but it can go up and up to 50% more, so it can increase up to 50% if multiple of them are sharing data. And as an example, there is here AppNexus. So if you measure the knowledge according to our telemetry that AppNexus has about the user, on average it knows 21% of the browsing history along 1 week. But then, if you estimate it through collaborations, so you say, okay, AppNexus might be receiving this data from those organizations, well, this number goes up to 73%, so almost more than 50% increase. We also looked at which kind of information do this tracker know, and for doing this, we looked at particular categories of websites, like those classically considered as sensitive, like websites related to political, health, sexuality, financial, religion, and legal topics. What we found was that health is the category in which most organizations, tracking organizations, are interested in. 34% of them are tracking health-related websites. But on the other hand, political is the category where more of them, like more organizations, are present in the same website. And we found an average of 15 different organizations per political website. More or less, we found a common behavior among the top 10 trackers, which means that more or less they are, tracking those categories with the same distribution, except for Google and Facebook, which they look to more or less be interested in all of them. So some takeaways of this study as well. As we've seen, like missing the user perspective, so only considering externally collected data and not internally collected data can lead to underestimate privacy risks. As we saw, main actors as Google, for example, know at least 2/3 of your browsing history. and how important it is to combine multiple data sources. So in this case, this allowed us to understand that also on the timing side, users really lose their privacy very fast, and it's not possible to prevent tracking by simply deleting the browsing history. So some conclusions. Of course, I mean, we didn't solve risk quantification. So risk quantification is still an open problem, but we showed as data-driven studies like ours, so data-driven solutions can provide actually an explanation. So can say, okay, this indicator can be used to somehow put a number of the on this risk. Some personal conclusion that I would like to share. So during my PhD, I had the opportunity to work with data, with large data, and it was really amazing. But it's amazing if you collect such data, so you know what you are doing. You collect data in a specific format, you save it, and then you are able to process it. But working with data, as I did, that has been collected at some point for some reason, is not such amazing. So it's slightly more difficult, which means that our studies show that data is a value, but sometimes data is just collected and left there without any purpose, without any format, without any reasoning before collecting it. So those studies are really, I hope those studies are highlighting the value of the data and foster for a better data collection. So thank you. I'm done with my talk. If you have any question, I will be able to answer them.